Hey everybody, this is Tony DeLigio with Plastics Technology Magazine. I'm joined today by Tom Moyak and his team at Matrix Tool and Len Hampton with Sodick Plus Tech. And we're going to be talking about their submission for the inaugural Hot Shots parts competition that we're going to be having at Molding 2021 this September out in Chicago. So I guess maybe to start off, Tom and Len, if you could talk a little bit about how this project came about, how the part came about, and maybe kind of special technologies that were used to achieve it. I know we have definitely some interesting stuff on the tooling side, and then also on the machine side with the Sodick machine that made this possible. So maybe Tom, if you want to start, talk a little bit about the project and how it came about and what you guys are trying to achieve.
Sure. We've been pushing the limits here from looking at the entire picture of small parts molding, micro, small feature molding, and leveraging our partnership with Sodick, using their excellent equipment, as well as partnering with our material suppliers as well, getting to even extremely thin wall molding, being able to flow into not only into thin walls but into longer distances through thin walls, things that are typically didn't seem very possible before. So we wanted to showcase those capabilities at our trade show, and it's difficult to get customers to approve using their parts for those types of purposes. So we decided that we would just develop our own part. It's not a commercial product. It's just something that we did specifically for the trade show, but we wanted to really make something that we couldn't make in our normal injection molding machines with a typical material.
I mean, going off of what Tom's saying, the features, micro features on the tool that Matrix built, and the idea and design, there's small holes, there's knife blade cuts. I think those features on the 4-cavity tool, not to mention very difficult material, is far and beyond any type of actual functional part you might have any other functional application. So we kind of really pushed Matrix kind of really pushed the limits and maximized the machine capability and designed the part accordingly. So
there's some. Let me add real quick. This is Dave Moyak. That I think when we sat down and talked to Len and talked as a group internally, we also incorporated pushing just traditional manufacturing paradigms, if you will. If you look at that tool, it's very small, and a lot of folks now build much larger tools for small parts. It doesn't have leader pins because we wanted to showcase that you can have exact precision alignment. So traditionally, people build a tool a certain way, and they always have for decades. And we, given the capabilities that the Sodick equipment allows us to utilize, we look at things a little differently than most, tool builders and molders, if you will. And we have 15-degree plastic engineers on staff. So when we take a look at a project and we know the Sodick equipment allows us to have additional capabilities that aren't capable in a normal horizontal molding machine, we took some of what I just told you and we incorporated it into this tool. So when you look at it, it's 4.5 by 5 inches wide, right? So you can basically hold it in the palm of your hand. And then it's running multi-cavity, it's capable of 4 cavities, and you can achieve a fast output cycle time. But then it has 60 knife edges in both steel and plastic. So a lot of times when you have intricate features in steel, oftentimes machines will struggle to fill and define that feature. And we find we have better success, and we're put in a position to succeed when we run that through a Sodick machine.
Okay, so this is a rendering of the part, but it's the scale and it's what we made. And when Dave was talking about knife edges in steel, that's this piece of steel coring this to a depth. That's a knife edge, okay? But there's also knife edges in plastic.
Show me the finish wall section.
So this, across this area here, which I just zoomed in pretty far, but straight across here is what's 4 thousandths and 8/10, about 0.12 of a millimeter, and just a little bit thick.
Pieces of paper.
Yeah, that's just one sheet of paper thick plus another 20% of a sheet of paper or something like that. And this one is one sheet of 1.3 sheets of paper across here. It's 5 2/10 thousandths, or 0.13 millimeters. So those are the thin, very, very thin regions that, you know, and it's not all, you know, we have LCPs that won't fill that as well. You know, but like, you know, this is designed to really push the limits. And this is what I was talking about. This, you know, the height of this little R down here is kind of like the just the length of an entire feature in this part, you know.
Yeah. No, and
so
you can see the lettering that you guys have there as well. And yeah, you would definitely need a magnifying glass to appreciate some of those features.
Yeah.
Well, I really appreciate the time today, and again, thank you for supporting the competition and entering the part.
Fantastic.
Thank you very much.
Thank you. Thank you.